Okay, this is the beginning of Chapter 3 in College Trig 3.1, and this has to do with radian measure and circular functions. So 3.1 has to do with radian measure, and if you look at my little graph here, and let's kind of move it over here and make it a little bit bigger so we can draw on it, see if we can kind of explain what's going on. Radian measure is used in advanced math because it gives us a chance to talk about real numbers instead of angles. Angles sometimes are a little bit hard to get. What is an angle? What is that definition? And a radian gives us a chance to use another form of measure rather than angles when it comes to what we've got here, which, like I say, what we normally call an angle here. Okay, so what we've got, where they came up with the radian is we have a central angle, such as what I have here, and the central angle has its initial side, the x-axis, with an angle measurement of theta. So this arc is theta, and it intersects this circle right here. Now, if the distance from here to here, which is the radius, is, if we took that distance and we laid it on the arc of the circle here, and it was also r, so the radius and this were the same length, then this distance from here to here, theta, is equal to 1 radian. If we took this and added another radius to it, like this, and we drew another one, this distance from here to here would be 2 radians, and 3 radians, 4, 5, all the way around. So that's what a radian is, and what we're going to learn in this section is how we're going to use radians. Alright, so one of the things that we're going to have to learn is how to convert degrees to radians. So first thing that we're going to do is give you a little bit of a conversion equality here. And we're going to say that 360 degrees, which is all the way around the circle, or the xy axis all the way around, is equal to 2 pi. And whenever we talk about the measurement of an angle in radians, it's always going to be using pi. So the distance all the way around is considered 2 pi. So the circumference of a circle, remember in your olden days when you had to learn circumference, it was 2 pi r? Well, 2 pi is that right there. So if we were talking about a 180 degree angle, that can be written in radians as just pi radians, because it's 1/2 the 2 pi. So we can use this relationship right here to develop a method for converting between degrees and radians. So here is the formula. We take our degree, so we'll take degrees, and when we want to convert these to radians, we take our degrees times pi over 180 degrees. Okay? And that will convert from degrees to radians. So for instance, if I have a 45 degree angle, I multiply it by pi over 180, and I get 45 pi over 180, and 45 goes into 45 once, it goes into 180 4 times, so 45 degrees in radians is pi over 4. 60 degrees times pi over 180, and a lot of these you'll start memorizing, and that's going to be 1, and that'll be a 3, so that equals pi over 3. If I have a 180 degree angle, I multiply it by pi over 180, those cancel, and I'm left with pi. Okay, so I can just multiply an angle by pi over 180, cancel things where I can or reduce, and I've just converted it from degrees to pi. All right, I'm going to show you another trick, and I don't know that it's really ever shown anywhere. I don't know if I made it up or I was taught by somebody really smart or what, but I know that this whole thing is pi. So therefore, if the whole thing is pi, then this 90-degree angle is going to be pi over 2. All right, so if I want to know what the radian is of a 270-degree angle, I'm doing 1, 2, 3 pi over 2's. And that is, if you took 270 times pi over 180, that would reduce to 3 pi over 2. And you can do that with an awful lot of these angles. So for instance, if I had, let's say, a 60-degree angle, okay, so I'm going to draw this, and I've got a 60-degree angle. Well, I know that a full 180-degree angle is pi, and how many 60s are there in 180? 3. So there are 3 60-degree angles in 180. So in other words, 1/3 of 180 is 60, or 1/3 of pi is pi over 3. So pi over 3 is a 60-degree angle. Now let's look at a 30-degree angle. How many 30 degrees are there in 180? There are 6. So a 30-degree angle is 1/6 of 180 degrees, or pi over 6. Okay, so hopefully this is sticking a little bit. Now what if I have a 120-degree angle? How many 60 degrees are in 120? There are 2 60 degrees in 120. There are 2 pi over 3's in 120, because pi over 3 is a 60-degree angle. Well, if there's 120 degrees, there's 2 of those. So 2 pi over 3 is the radian measure for 120. And if you don't like doing it that way, just do it this way. Just multiply your angle all the time by pi over 180, and that will reduce to 2 pi over 3. Okay, so you can choose whichever method you like. I like using both of them, actually. It just kind of depends on what I'm looking for. All right, so let's look at going the other way. Let's say that I gave you the radians, and I want you to convert it to degrees. Well, it's very similar. The only difference is when you're given pi in your measure, that means you're in radians, and in order to change it to degrees, we flip it upside down and multiply it 180 times pi. Now, one of the things that helps me to remember, and this is just me, is when I write this, the reason I know it's 180 over pi instead of pi over 180, I don't get them mixed up, is because my pi's have to cancel. Because if I'm changing to degrees, I can't have pi's. Pi's are only showing up in radians. So that helps me to remember, okay, is it 180 over pi or pi over 180? Well, I have to be able to cancel my pi's in order to make that work. And so that cancels to 1, and that cancels to 45. So 9 times 45 is going to be 405 degrees. So if I have 4.25 radians, and I need to change that to degrees, I'm going to take 180 over pi. And this time, what I'm going to have to do is I can't cancel my pi's. So I just get my handy-dandy calculator and take 4.25 times 180 and get 765 divided by pi. And when I divide that by pi, I get 243 degrees, 243.5 degrees or 243 degrees, 30 minutes, depending on what they want. But they said to do it toward degrees, so I just did it in degrees and minutes. Very important to understand is, on this last one, all I did is it said 4.25. If there is no degree sign up here on the measure, then it is in radians. You assume that it's talking radians. So if I ask you, if I just say we have 30.625 and I don't put degrees, assume that that's in radians. So know that 30 degrees and 30 radians are two completely different things. All right, so there is a table on the bottom of page 95, and what that table is all of those conversions that I gave you earlier on how to find them by hand without having to use a calculator or a table to remember. So you can go from degrees to radians or radians to degrees fairly easy, and a lot of it is like pi over 6. I just know that that's a 30-degree angle just because I memorized it. And one of the things that I do in order to know that this is a 30-degree angle is I just ask myself, how many 6's are in pi? How many 6's are in 180? 30. If I have pi over 4, how many 4's are in 180? 45. If I have pi over 3, how many 3's are 180? There are 60. If I even get to something like, let's see, 3 pi over 2. Again, I say how many 2's are in 180? There are 90. 90 times 3, 270. So that's a 270-degree angle. So I don't know. That's just one of the ways I do it. You don't have to do it that way, but if you look at page 96, there is a huge wheel there on how to figure out all of these, or not how to figure out, a kind of a cheat sheet in order to figure these out. So what if all you had to do was just ask yourself those basic questions, like if we had 4 pi over 3. How many 3's are in 180? There are 60. 60 times 4 is 240 degrees. So that's what that angle is. 4 pi over 3 is a 240-degree angle. If I had something like 7 pi over 6, how many 6's are in 180? There are 30. 30 times 7 is 210 degrees. So it's just so easy to convert these. 7 pi over 4. How many 4's are in 180? There are 45. 45 times 7 is 315 degrees. Okay? So that's how I do it when I'm looking at angles, and notice that these angles that we're talking about are 15 degrees apart. You can figure out pretty quick, pretty easily in your head, any angle from 0 to 360 that are 15 degrees apart. 15, 30, 45, 60, on up, all the way around to 360. So not too terribly difficult. All right, let's look at example 3. So example 3 is saying find each function value. So we have the tan of 2 pi over 3. Well, I know that 2 pi over 3, because I've learned these over the years, is 120 degrees. So now all I do is take my calculator and plug in 120 degrees, and I get negative square root of 3. If I'm looking for the sine of 3 pi over 2, I know that is going to give me a 270-degree angle. sine of 270 degrees, which is another one of those things you could really do in your head, is going to be negative 1, because if you've got your thing here, you go over 270, you get to that angle right there. You got one of your quadrantal angles, and if it helps to kind of draw a triangle as it's moving closer and closer to the 270 mark, what happens to the opposite side? It becomes the same length as my hypotenuse as it gets closer and closer to this line until it's one line in itself. So that's where I got negative 1 for an answer. All right, the last one is cosine. Let's get rid of all this stuff. Cosine of negative 4 pi over 3. So I've got my xy axis here. I start here, but it's negative, so I'm going to go this way. And how far am I going to go that way? Well, a little bit further than that. Let's go up like that, because 4 pi over 3. Pi over 3 is a 60-degree angle. 60 times 4 is 240 degrees. So I came this way 240 degrees, which means that my reference angle is going to be 60, because 180 plus 60 is 240. All right, so I'm looking for cosine. So the cosine of a 60-degree angle in the second quadrant, all students take calculus. Sine is positive there, therefore my cosine is going to be negative. So my answer is going to be negative. I'm going to take the cosine of 60. Well, the cosine of 60, this is 1, this is 2, that is the square root of 3. Cosine is adjacent over hypotenuse. There we go. There's the cosine of negative 4 pi over 3. Now see, I didn't use a calculator at all doing this. And I went and found the cosine of 4 pi over 3 equals negative 1/2. And I bet you that most math teachers, most math students could not do that in their head anymore, because they're so used to relying on a graphing calculator in order to figure this stuff out. I'm trying to get you to understand how this works and how to do this on your own, so that when you use a graphing calculator, you get it. You understand what the graphing calculator is doing. And anyway, it might come a little bit easier on me because I've been doing this since the spring or fall of 1979, and I kind of get it. So anyway, it will come, and you'll be able to look at these and be able to figure it out by hand. All right, so that's it for 3.1. The next video will be on the problem set.